Anybody? We've talked about this before. The Finger Lake homes. Go back to our log cabins, A-frames, and colonials. Remember what we said about A-frames? They just look like an A-frame, and they have a loft up top. Colonials, we call those in the suburbs. They call them snout houses, or the urbanists call them snout houses because they're two-story. And then then a log cabin is a log cabin, and it could be actually a log cabin could be a colonial, but let's not get into that. So these are actually independent as well. And the whole purpose of this analysis is to decide, is what you're observing different than what you expected? And that's what this calculations are going to be based upon. And here are your observed frequencies. Right? And so everything has to equal to one. This would be actually have to equal 100% or 1.0 as normal. And as you come across here, 1.0. As you come down here, 1.0. And all these percentages have to add up to this percentage over here as a proportion. So if you had, well, let me just go to the next. So that's what you observed. Now your expected frequencies this is the formula, and divided by your total sample size. You take the I and the J intercept point and divide by the total sample size. Let me show you how that works. And here are the expected frequencies. This is what you would have expected to have occurred based upon the I and the J and the overall 360. So if you took, let me see, 135, and this all adds up to 135, and you would have expected that based upon the observed frequency, you would have to have about 75% would be colonial and 25% would be they would all be 135, so that'd be all the colonials, and then likely to repurchase would be about 75 versus 25%. That's what you would expect to see. And then we run an analysis of here's what we observed, here's what we expected, and what is the difference between the expected and the observed, to find out if there's something going on in this model. Is there something to write home to Aunt Emma about, to Aunt Jane, or I forget all the other aunts we had in here, okay? And so you come down here and you create this chi-squared value. And here's your rejection rule. Here's the critical approach. If your chi-squared is greater than the chi-squared of what you would, of the chi-squared at the test value that you're running, or the p-value that you're running the test against. For example, if you're running at p.05, this would be chi-squared at p.05. And you're going to, and then you have some degrees of freedom that you have to take into account. So you go to the back of your text, and I'm not going to do this one because you can go to the back of your text as necessary. But what I'm going to show you here is that here is your value, your critical value of 5.991, and where you'd get that. Well, let's just go through it real quick. You'd go back to your chi-squared chart in the back, and then you would come up with this value of 5.991. And then you've got your test statistic. Here's the p-value approach. You determine that your test statistic is 5.067. It's less than 5.991. So therefore, what would you do? Do not reject. Cannot be rejected. And then it's going to actually, and then you can actually calculate the p.079.